Okay, we're looking at the Geometry Unit 4 review. We are going to look at these questions, which are going to be very similar to the ones that you're going to see on the test coming up. This actually reviews Units 1 through 4. Several questions of dealing with proofs, but mostly dealing with previous lessons. Since we just studied for the benchmark, we should be pretty fresh on the information that's in here already. So let's take a look at this first question, number 1. Make a conjecture about the next item in this sequence. So we went from 6 to 18. Well, to go from 6 to 18, we either added 12 or multiplied by 3. Well, to go from 18 to 19, we definitely added 1. To go from 19 to 57, well, adding 12 is not going to be correct because that would get us to, what, 31? But multiplying by 3 would get us 57, and then from 57 to 58 would be adding 1. So we are multiplying by 3, adding 1, multiplying by 3, adding 1. So the next thing we should do to 58 is multiply by 3. 58 times 3 is 174. The answer there is C. Number 2. The measure of two complementary angles are 5q minus 6 and 4q plus 15. Well, if these two are complementary, then if I add them, (5q minus 6 plus 4q plus 15 equals 90 because they're complementary. Combine like terms, 4q and 5q is 9q, and negative 6 plus 15 is 9. Subtract 9 from both sides, and 9q equals 81. Divide by 9, and q equals 9. Now be careful here because it says find the measure of the angles. That means if q equals 9, we're going to go ahead and plug them back into each of these to find the measure of each angle. So 5 times 9 minus 6, that would be 45 minus 6 is 39. Well, A is the only one with 39. But if we did that to the other one, 4 times q, which is 9, plus 15, 36 plus 15 is 51, so yes, A is my answer in that case. Alright, let's look at the next one. This one says that A and B are supplementary angles, and that the measure of angle A is 4 times the measure of angle B. So when I add these two together, I get 180 degrees. They're supplementary. So what I'm going to have to do is say if angle A, let me zoom in over here. If angle A is x, then angle B is going to be 4 times x, 4x. So that means, I'm sorry, I have that backwards. Supplementary angles, the measure of A is 4 times that of the measure of angle B. So actually what we should have is the way we can look at this is say which one's bigger. A is definitely bigger than the measure of angle B. So yeah, that was correct. I'm sorry. So 4 times the measure is 4x. So if the larger one is, so 4 times A is going to be what B is. So they're supplementary. Now one thing we could do, we could look and see in our answer choices which one is 4 times the other angle and get to our conclusion there. Or we can actually say x plus 4x equals 180. So 5x equals 180. Divide by 5. And we get x equals 36. So that means that angle A is 36, and I'm sorry, I did mess this up. It should have been 4x. I'm struggling right now. Angle A is equal to 4x. Angle B is equal to x, because angle A is 4 times as large as angle B. So I apologize for that. But we still end up with the same equation. We get x equals 36, which means angle B is 36. And angle A is 4 times 36, which is 144. So A is 144, B is 36, which is answer D. Okay, sorry about that confusion. Hopefully I didn't confuse you too much. Okay, number 4. It says, determine whether the conjecture is true or false. Give a counterexample for a false example. Okay, so A, B, C, and D, we have these points. Our conjecture is that they are all coplanar. They could be coplanar, but just because we have 4 points doesn't mean that they're coplanar. So let's look at the choices here. We're going to say that it's false. It's definitely not true, because we can think of examples where they're not coplanar. They don't have to be on a straight line. Well, that's really unnecessary, because that wouldn't prove that they're not coplanar. 2 points are always coplanar, but 4 are not. That is not true. The one you should really recognize is that 3 points are coplanar, but 4 are not. 3 points are always coplanar, but anytime we add a 4th point, we can add that 4th point anywhere and it would not be coplanar. Okay, name the property of equality that justifies this statement. So we have G equals H, and then we added a K to both sides. The reason that we can use that we can do that, is because of the addition property of equality. Okay, 6 says, state the property, name the property of congruence that justifies the answer. LM equals PQ, PQ equals LM. Well, when I flip those, it doesn't matter which one is on the right side or which one is on the left side. We use the symmetric property of equality to say that doesn't matter which side it's on, they're still the same thing. They're still equal to each other. Substitution property of equality. If y equals 6, then 8x plus y equals 13. What we're doing is we're substituting y with 6. And which one does that? D. They took the y and they put the 6 in place of it. Okay, looking at number 8 here. Transitive property of congruence. Remember, that one, if you think about that one as if A equals B and B equals C, then A equals C. So if C equals D and if CD is congruent to EF and EF is congruent to GH, then CD is congruent to GH. That's D. Write an equation for the vertical line that contains the points negative 3, 1. So basically we've got negative 3, negative 1 somewhere over here. It's a vertical line. So what's the equation? For a vertical line, our equation always starts with x equals, and it's equal to the point on the x-axis where it crosses. That crosses the x-axis at negative 3, so x equals negative 3 is my equation. Okay, number 10. We've got a midpoint of SU. Find the values of x and ST. So T is the midpoint. that means, and you can't really see it here very well, but that should say 8x, and that should say 5x plus 27. So if t is the midpoint, then these two segments are equal to each other. So 8x equals 5x plus 27. Then we solve for x. Subtract 5x, so I get 3x equals 27. Divide by 3, so x equals 9. It eliminates that and that. It asks for st, which is this segment. 8x, so I'm going to plug in 9 for x, and I get 72, so my answer is D for number 10. Okay, number 11. It says 3 and 5 are, we're just naming these types of angles here. 3 is here, 5 is here. They are on opposite sides of the transversal. They are alternate interior angles. Number 12, 1 and 7. There we're dealing with alternate exterior angles. Remember, inside the parallel lines, or I'm sorry, in between the two lines that are cut by one transversal, this is the interior. Outside of that is exterior. That's why you'll see that 1 and 7 are on the exterior side of that, whereas the previous question they were on the interior. Okay, number 13, find the coordinates of the midpoint given these two endpoints. We take our x's, 6, and we add them together, and we divide by 2. We take our y's, and we add those together, and we divide by 2. 6 and negative 11 is negative 5 divided by 2, and then we have negative 10 divided by 2. So we get negative 2.5 and negative 5 as our x and our y, which is D. Okay, hopefully you can read enough of this, or at least check your paper to see if you can read it. LHO is right this angle right here, and NKP is this angle right here. And because those are congruent, what can we use to show that lines are parallel? Well, the lines that are parallel here are going to be this line and this line, because these three lines are the only ones that we're working with. So these two lines right here are the ones that are parallel, and if you can't read that, those are A and B. So CD is out. And what type of angles are these? They are alternate exterior angles. So my answer here is C. And number 15, which condition will guarantee that L is parallel to M? Well, if 5 and 7 are congruent, look at that. We're talking about this and this angle. Those are vertical angles. They're congruent. It has nothing to do with parallel lines, so that's out. 1 and 3, again, vertical angles. That doesn't prove lines parallel. 1 and 7, I've got this angle and this angle. Actually, those are alternate exterior angles. If they're congruent, lines are parallel, so that's my answer. 6 and 5, just to look at that one, we're talking about this angle and this angle. Those are a linear pair. That has nothing to do with parallel lines. Okay, number 16. We're needing to come up with a line that's perpendicular. Remember, you look at the slope, you take the opposite, so the opposite sign, so that's positive, so ours is going to be negative. And that is 2 over 1, so we write the reciprocal, we flip it, so we'd have 1/2. So which of those has a slope of 1 negative 1/2? D. Now be careful, whatever is right here, the y-coordinate, doesn't even matter. We don't even have to look at that. Just as long as the slope is the negative reciprocal, then it's going to be perpendicular. 17. The 5 blades of a ceiling fan form a regular pentagon, which counterclockwise rotation around point P maps D onto A. So we've got D here. We're going to go counterclockwise, which is this way. So we're going to go 1 rotation, 2, 3. Now what does each one count as? Well, 1 full circle would be 360 degrees. Notice that we have a total of 1, 2, 3, 4, 5 vertices. So we're going to divide 360 by 5, and we're going to get 72. That means with each rotation, it's 72 degrees. Or at least I say rotation, where it would map onto itself. So we counted, when we did this, 3 from D to A counterclockwise, so we would multiply 72 times 3, which would leave us with 260 degrees to map that again. Now remember, on number 18 it says, what is the order? The order is the number of rotations in a 360 degree turn where it would map onto itself. We counted the vertices would be 1, 2, 3, 4, 5. So the order in this case is 5. And number 19. What is the image of the point 4, -1 after a reflection across the y-axis? So let's look at this. If we wanted to, we could say, let's graph this point. 1, 2, 3, 4, 1. That's where this point would be. If we were to reflect it across the y-axis, remember this is the y-axis, and we're going to say it's going to be the same distance from the y-axis as it is here. So that's 1, 2, 3, 4 away, so we're going to go 1, 2, 3, 4 away. So what would that point be? It would be 1, 2, 3, 4, -4, -1. So we could draw a picture. Not only we could use the chart, we could draw a picture. Either way we do it, I'm going to get A for my answer. Okay, this one, hard to read. Let's go ahead and just rewrite that. We've got 4y here, we've got 140 here, and you've seen this problem before, 8x plus 4. We're going to set up the appropriate equation to solve for x. Well, 8x plus 4 is vertical to the angle that's 140 degrees, which means that they are equal. Then we'll solve for x. So 8x plus 4 equals 140. Subtract 4 from both sides. Divide by 8. And x equals 17. Set up the appropriate equation to solve for y. Well, notice that these two angles are a linear pair, which means they're supplementary. So 4y plus 140 equals 180. Now solve for y. 4y plus 140 equals 180. Subtract 140 from both sides, and 4y equals 40. Divide by 4, and y equals 10. And that's my answer. Okay, number 21, write the converse, inverse, and contrapositive of the following statements. So here's my conditional statement. If a figure has 4 sides, then it is a quadrilateral. The converse is going to start with the conclusion first. So we're going to say if a figure is a quadrilateral, I'm going to shorten it a little bit, then again, this is where I go to the hypothesis here. It has 4 sides. The inverse is where we write it the exact same way, but we just put not in there. If a figure does not have 4 sides, then it is not a quadrilateral. You can read that. And the contrapositive is where we flip it and we add the word not to it. So we're going to say if a figure is not a quadrilateral, then it does not have 4 sides. Okay? If the conditional and the converse are true, write the biconditional of the statement. Remember, if they are true. So let's look at the conditional statement, starting with this. If a figure has 4 sides, then it's a quadrilateral. Well, that's true. If we name shapes based on the number of sides, if it has 4, we call it a quadrilateral. Now the converse, where we flip it, if a figure is a quadrilateral, then it has 4 sides. Yes, that is also true. So this biconditional statement we can write because the conditional and converse are true. So a figure has 4 sides, and this is the biconditional. And this is where we write it differently. If and only if it is a quadrilateral. Okay, that's how we would write that as a biconditional. Okay, law of detachment. You remember the law of detachment says that we start with a conditional statement. If 2 angles are complementary, then the sum of their measure is 90. Hypothesis, conclusion. Now look at this. This is very similar to the hypothesis. E and F are complementary. Therefore, we can say that E and F, what does the conclusion say? Their sum of their measure is 90, so we can say the measure of angle E plus the measure of angle F equals 90. Since they're complementary, then their sum is 90. 23, use the law of syllogism to draw a conclusion from the 2 given statements. Remember, this is very similar to the transitive property. If you exercise regularly, you have a healthy body. If you have a healthy body, you have more energy. Since we combined it with these 2 statements, they're the same, we can combine these 2 statements for a new conditional statement. If you exercise regularly, then you have more energy. And number 24, fill in the missing reasons. So this is a proof which we're going to put reasons for. Again, remember the first reason is always going to be given. That was given to us. Well, the measure of angle 1 equals the measure of angle 3. What did we do right here? We added the measure of angle 2 to both sides. We can do that because of the addition property of equality. Well, now we're saying that the measure of 1 plus the measure of 2 is equal to AFC. The measure of angle 3 plus the measure of angle 2 is DFB. The 2 smaller angles add up to the larger angle. That's the angle addition postulate. And now we can say that using substitution, since the measure of angle 1 and 2 is AFC, we can write it in place of what was in step 1, and the same for DFB. So the reason there is substitution. Okay, define the types of transformations. Which one's equivalent of 2 reflections across intersecting lines? The answer to that is going to be B, rotation. What do they do? Remember, a translation is a slide, a rotation is a turn, a reflection is a flip, and a glide reflection, think of glide first, which is similar to slide, and then a reflection, which is a flip. Okay, but remember, rotation is the same as two reflections across intersecting lines. 26, 5, 3 is the midpoint of RS. So let's count 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. So this is M. It's the midpoint of R segment RS. The coordinates of S are 1, 2, 1. So there is S. And it goes through M. Now it continues to go. What are the coordinates of R? Show your work or explain your method. Well, we could use the midpoint formula to come up with this. We could also say that the distance, we could use the Pythagorean theorem to say, well, that distance right there is going to be the same as that distance right there. So it's up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. Draw my triangle a little off. So we should get the point right there, which if we counted it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, should be 9, 4. And we could have looked at it that way. We could have done where we said 1 plus x over 2 equals my x coordinate of my midpoint, multiplied both sides by 2, subtract 1, and x equals 9, and then had done the same thing for my y coordinate and said 2 plus y equals 3, multiplied by 2 to get 2 plus y equals 6, subtract 2 from both sides, and y equals 4. Okay, so you could use that equation method or that method. Number 27, we're going to use the distance formula or Pythagorean theorem. Remember, when we have a picture, it's a lot easier to use the Pythagorean theorem. And what we do is we make a triangle to find the distance. This distance we know is 2. This distance is 7. So to use the Pythagorean theorem, we're wanting to know what this one is, so we'll call it x. We now have a triangle. We'll say 2 squared plus 7 squared equals x squared, which is WT. So 4 plus 49 equals x squared. 53 equals x squared. We take the square root of both sides. 53 cannot be simplified, so the answer is square root of 53. Much easier than using the distance formula. Okay, now this one we're going to reflect it across the x-axis. So if you'll remember here, we're going to basically take each vertices and move them over the x-axis the same distance that they are. For instance, B is 1 unit away on top of the x-axis. Again, the x-axis is right here. So we're going to move the next, translate that spot 1 unit below the x-axis, which that point would be the new B. The old B is 1, 2, 3, 3 over 1 up, so 3, 1. The new B is going to be 3 over 1 down, so 3, negative 1. You can probably see where this is going. A is going to be at negative 2 over and down 1, so negative 1. But notice that's 1 unit below. That's 1 unit below the x-axis. So we're going to move A to 1 unit above the x-axis. That's my new A. So that new point is going to be -2, +1. C is 1, 2, 3, 4 units above the x-axis, so we're going to move it 1, 2, 3, 4 units below the x-axis. Connect these dots, and we're going to have our picture, or our translated figure reflected, transformed figure reflected over the x-axis. Now C, its original point was 1, 2, 3, 4, 5 over, 1, 2, 3, 4 up, 5 over, 4 up. So now we could have probably plotted that point, because we would see that what we're doing is we're taking x and y and we're keeping the x the same, but we're changing the sign of the y coordinate. Alright, and the last question. This one right here. We're going to find the values of x and y. So here we have parallel lines. We have corresponding angles here. So we can set 7x minus 28 equal to 5x plus 12. Subtract 5x from both sides. Add 28 to both sides. Divide both sides by 2. And x equals 20. Well, when I do that, I can find the measure. This linear pair is supplementary, but I need to know this angle. So I'm going to plug in 20 for x and find out what that angle measure is. 5 times 20 is 100, plus 12 is 112. So 112 plus y equals 180, because these two angles added up form a linear pair. Subtract 112 from both sides, and I get 68. So y is equal to 68, and that's my answer. Okay, B here. I have parallel lines, so I have this angle is a vertical angle to this angle. So this angle right here is also 6x plus 12. Notice that these are interior angles. I'll mark it with blue here. This angle and this angle are consecutive interior angles, which means they're supplementary. So 6x plus 12 plus 54 equals 180 degrees. Combine like terms, we get 6x plus 66 equals 180. Subtract 66 from both sides, and 6x equals 114. Divide both sides by 6, and x equals 19. That's the value for x. And the last one, find the value of x. Again, this is the same situation. These two are consecutive interior. So 6x plus 12 plus 4x plus 18 equals 180. They're supplementary. Combine like terms, 10x plus 30 equals 180. Subtract 30 from both sides, and 10x equals 150. Divide both sides by 10, and x equals 15. Okay, hopefully that review helps you to prepare for the Unit 4 test.